Hi guys, so today we're going to start chapter 3, parallel and perpendicular lines. And today we're going to look at the first three sections and let's get into it. So first, let's look at 3.1 on identifying pairs of lines and angles. So first, let's look at some key terms. Basically, in this chapter, the most important thing is probably going to be parallel lines as it becomes the basis for everything you do, like alternate interior angles and even more. So first, parallel lines. So two lines that do not intersect are either parallel lines or skew lines, and two lines are parallel if they do not intersect and are coplanar. So they're on the same plane as seen here, but they never intersect or that, in other words, touch each other. And two lines are considered to be skew lines if they don't intersect and are not coplanar. So maybe there's one line here and another here, and that would make two lines skew. And also two planes that do not intersect are parallel planes, similar to how parallel lines work. So let's look at two more postulates. First, the parallel postulate. So if there's a line and a point not on the line, then there's exactly one line through the point parallel to the given line. So if there's a line and a point not on the line, so this is seen here, so there's exactly one line going through P to line L. And the perpendicular postulate is if there's a line and a point not on the line, then there's exactly one line through the point perpendicular to the given line. So there's one line. This is pretty straightforward. Next, so these four things are probably one of the most important parts of the entire chapter, so make sure you know it. But first, let's look at a transversal. So it's a line that intersects two or more coplanar lines at different points. So something like this would be a transversal. So now looking at the four angles formed by transfer. So first, a corresponding angle. So two angles are corresponding angles if they have those corresponding positions. So you can think of this as like when there's a drawing like this, the same place here. Uh-oh, it would be here and here because they're kind of in the same spot, just on a different line, and are intersected by a transversal. Basically, that's corresponding. But alternate interior angles is two angles that lie between the two lines on the opposite sides of the transversal. So we can see this here, like these two are alternate interior. So you can always think interior is inside. So these two, the ones closer, and similar exterior is the same idea, but they're farther out. Like alternate exterior angles lie on the opposite sides of the transversal, but outside. And consecutive interior angles, basically, their two angles are consecutive if they lie between this two lines and are on the same side of the transversal and they equal to 180. So they're just like next to each other like this. And that would be the idea for consecutive interior angles. So let's just look at angle relationships here. Copy and complete the statement. List all possible correct answers. So first, BCG and blank or corresponding angles. Let's see, where is BCG? BCG is here, right? And we're trying to find a corresponding angle. In this case, the corresponding angle would be angle BC. Oh. So BCG would be here, and because you're trying to find a corresponding angle that's in the same spot, basically, that would be angle JFC because they're in the same transversal and they are thus corresponding. Next, let's find two consecutive interior angles. So BCG, let's see, is once again here, and its consecutive interior angle would probably be something like angle HJC because they would be in a consecutive relationship. And next FCJ, let's see, where is F? FCJ, so this angle and its alternate interior angle could be right here. So these are like two alternate interior angles. And angle FCA is right here. And its alternate exterior angle could be something like angle GJH. So this is pretty simple, just basic angle relationships. Let's move on. So we next on use parallel lines and transversals. So first, let's look at the corresponding angles postulate. Basically, you remember that corresponding angles are right or angles in this kind of relationship. And this postulate, all it's saying is that these two angles are corresponding, thus they're the same angle measure. Or in other words, they're congruent. And these next three ones, just remember that corresponding is the only postulate and everything else is a theorem. So you can see here that if you look at the alternate interior angles theorem, basically alternate interior angles like these are congruent. Same with exterior angles. But how a consecutive interior angles theorem states that they're supplementary, or basically the two angles add up to 180 degrees. And next, let's just quickly look at 1819 and let's see. So first, measure angle 1. So we're finding measure angle 1 and 2. Explain your reasoning. So because we know here's 140 degrees, we know that number 1, angle 1 must be 140 degrees as well because of the alternate interior angles theorem that states that they're congruent. And by the consecutive interior angles theorem, measure 2 is 40 degrees because these two are supplementary. And here, let's look. Because of alternate interior angles theorem, 1 is equals 122 degrees, and because 180, because of the consecutive interior angles theorem, measured angle 2 is 58 degrees. And this is pretty, honestly, simple, but let's look at a quick proof. So looking at like 41. So if two parallel lines are cut by a transversal, then the pairs of consecutive interior angles are supplementary. So our proof of the consecutive interior angles theorem, and we're given these two measures are these two are parallel. Okay. So first, it's quite difficult. Wait, actually, let's find one with a chart. Okay, nothing has a chart. Great. So first we know that this is given because we know that these two lines parallel. Next, because we know the relationship of the two angles being parallel, we can see that measure angle 1 is congruent to measure angle 3 by alternate interior angles theorem. And because we know how basically supplementary angles work, we know that measure 2 plus measure 3 would be 1. Measure 3 is equal to 180 degrees by angle add postulate. And because we know that here measure angle 3 and 1. Oh, it's but the reason here would not be angle addition, but would be definition of will be the linear pair postulate, not necessarily a definition. Linear pair postulate, and then measure angle 2, and we know that measure angle 1 and 3 are congruent, so we can substitute it to get substitution property of equality, and we're done.
I think that was pretty simple. So these proofs are not really hard. It just requires you to kind of think about it, right? Next, let's just move on to proving lines are parallel. Let's look at the corresponding angles converse. So like you guys probably remember that converse is just the opposite of not, it's something that's not a converse. So we know that because the corresponding angles postulated from earlier says that if two angles, um, if the lines are parallel and they're cut by transversal, then the corresponding angles are congruent. Was basically what the postulate said, and here we're just saying the opposite. So if it is cut by transversal and then the corresponding angles are congruent, then the lines are parallel is the conclusion here. And here, all these converses, basically it's the same thing, just the other way around. And let's look at the transfer property of parallel lines. Basically, you know that the transfer property is like a link, like A is equal to B. Wait, that's a bad one. Hold on. A is equal to B, and C is equal to D, and let's say that B is equal to C. Then you can make a link like D is equal to B and C, and so on and so forth. The transfer property of parallel lines has that if two lines are parallel to the same line, then they're parallel to each other. We can see this like here. So quickly, if you look at also let's just look at some proofs because I think everything else is pretty easy here. For example, 31. Copy and complete the proof. Measuring angle 1 is 115 degrees. Measuring angle 2 is 65 degrees. Prove that M and N are parallel. So basically this is telling you to prove this. So first we know this measuring angle 1 by the consecutive angles theorem, and supplementary by the, I don't know, honestly this is just like some definition of supplementary angles. And we can conclude that M and N are parallel from this because of the that's like the idea here. Like looking at 34 because we know one. So if you're trying to prove that AB and CD are parallel to each other, then you would have to show that a relationship. So here, for example, you have actually have quite a bit of angle pairs you can use, and you can conclude that these lines are parallel by showing its converse. So for example, you could do the converse of the alternate exterior angles theorem for these two angles that are in a relationship like that. So it's pretty straightforward. All you need to do is apply the trans theorems and postulates you've learned so far. So guys, great job today, and see you later next time to look deeper into parallel lines. Bye.